Special functions, here's the first one. You have to really understand domain to understand this, okay? So I hope you all really understand domain.
Hey, when they ask us to give a domain, it tells us to use like -2, -1, 0, 1, 3. Right? Is that what it
Say again?
Like when it tells, like when it doesn't give us a domain, it wants us to use like certain ones, like -2, -1, 0, 1, 3.
For these, yes, it will be. Let me show you one come out. Piecewise is exactly what it sounds like. It's pieces of different graphs put together to make up one graph. Okay, you have probably seen this. This is all over standardized tests. You see it all the time. Okay. I don't know what Pennywise means, what you're talking about. What does that have anything to do with this, though?
It sounds like Piecewise.
Oh, oh my goodness. Okay.
It's the P and the Y.
Let me show you what it looks like, then I'm going to go to the next page to actually graph it. I'm going to use this one out of your book because it's a nice, easy.
What is an example?
Yeah. This is, I just want to show you what they look like.
How do you draw those squiggly? You just draw it.
I don't know. How do you draw a circle? You just put your pencil on there and draw it. And I kind of, it's just a little whoop.
X minus 1 if X is less than 1?
All right, so here's what this is saying. Do we see that these are two linear equations?
Yes.
Okay, linear equations are easy for us to graph, right? Sometimes. We hope that they're easy for us to graph. Okay, so the first one has a y-intercept of -1 and a slope of, which means I go to -1 on the y-axis, and then I go up 1 over 1, up 1 over 1,
How do you know
up
it's
1 over
negative
1.
It says -1. It says -1. Okay, so
mx plus b.
Where's the y?
Yes, f of x means y.
I know. Why?
mx plus b. M is the slope, b is the y-intercept.
I'm confused.
I got you now.
Wait,
I actually got it now.
Yeah, no, I got that one.
But it's like I had it first, but now.
This is the equation, but this is saying this is the equation only when x is smaller than 1. So I cut off all the rest
So
of the
basically you
line.
start it at 1 and go...
And you go smaller,
down.
exactly. And then you look at the,
So the first x is the y.
and then you look at the second one.
So the first x is always y.
Uh-oh, it's
Trash.
What is it doing?
I think it's catching up with your sleep.
I think I am.
It's shutting down.
You're laying on your sleep.
Well, it's still casting from my side though.
Press back.
It's Pennywise.
Oh, it's okay.
Audio.
Then when I look at the second equation, x plus 3, what's the y-intercept? 3, and the slope is?
1.
So I start at 3 and then I go up 1 over 1, up 1 over 1, right? That's easy. But it's only when x is greater than or equal to 1. Okay? So I got two different lines and I'm going to cut them off at the same spot. One of them's going to go to the right forever, one of them to the left forever. And so let me show you what that looks like. That's what I would, okay, so that's the way that I tell everybody to graph piecewise. To me, it's easier. It's easier to understand if you graph the whole line and then you erase what doesn't apply. But it's easier to actually graph if you take what you have. Let me just rewrite it. No, I'm just going to rewrite because we're going to. You're always restricting the domain on the, yes. Theoretically, you should have hit this in Algebra 1 at some point. Because this is an easy linear function, but we'll be restricting some more complicated functions here real soon. So this is just kind of a recap, but I'm going to assume maybe you didn't get to it.
For what?
Piecewise.
No.
Okay. Okay, well, here we go. All right, so what I want to do...
Are we still in Algebra 1?
No, this is Algebra 2. It's just that in Algebra 1, you would do piecewise of linears, and in Algebra 2, we get into piecewise of a little more complicated functions. We're just going to amp it up. All right. So as I look at this, I talked about what it means. The easiest way for me to graph these is if you plug in the domain restriction. So I say, let me take this first equation, x minus 1. When x is less than -1. Now understand that's less than, it means it does not include -1, right? And I'll show you why that's important once we get it on the graph. If I plug in -1, so f of -1, what do you get?
Eight minus one. No, I don't know.
-2.
Equals -1.
-2. What am I doing?
You're adding it, Dylan.
Oh, you plug it in, that's right.
Okay. Now, because it does not include this point, I'm going to have to do an open dot. Okay, so -1, -2.
Why did you plug in -1?
That's my restriction. It stops there, and it's going to go off forever in one direction, left or right. But I'm looking at where it's restricted, and that's where it's restricted. So I plugged it in to find the endpoint, essentially, is what I did. This is what you do. Yep. All right.
Wait, don't erase it.
You already know the homework about to be long.
Wait,
So we
so
did, Dylan.
first X is always y.
So we did, is that all we did?
It's always plugged in.
I genuinely think we should have 3 times as much homework over the weekend.
All right, look, we plug in, take the restriction and plug it in. Okay? Once you have that plugged in, now I need the rest of the line. Remember, this was a whole line, and don't put this on your paper just yet. Let me just show you. It was a -1 y-intercept, right? And then it went up 1 over 1. So if I connected it,
No, but it has to be less than -1.
it was like that, right? That's the original line without any restriction. But if I restrict it and I say x has got to be less than -1, here's -1. That's exactly right. I would take away all of this, and what's left is that piece of the function, right?
Exactly.
So essentially that's what I'm doing, but I'm plugging in the restricted part first.
When I look down,
No, no.
I forgot to hit record on that.
is there a dash line?
All right, no, we're not dashing. We'll just be open or closed. So now I need to look, if you think about that white line before I erased it, right? That's what's going this way. So if it's got a slope of 1, that's up 1 over 1, but I need to go the other way. So I'm going to go down 1, left 1, so that it still has a positive slope, okay? But I'm just taking that part of the line that falls when when x is less than -1, yeah.
Okay, then, that open circle.
Yeah.
Like, how did you get -1 and -2?
I took this -1 and I plugged it in my equation.
Okay,
So you take it
so
back.
you take the -1 and take the -2. So
That's the point.
X would be -1 and then 2 is what you get.
-2 is the y. Right, so when you plug it in, so -1, -2 is a point on the line.
So you can put y equals -2. Like
Yes.
whatever.
So
Yes.
you're using the front one,
Mm-hmm.
you're plugging in the front.
Yes.
Okay.
From the bottom equation, what do you want to
Same graph. The two pieces together make up the one function. Okay? That's why it's called piecewise. It's a piece of this graph and a piece of this graph. So now look at the second one. I'm going to follow the same procedure here. I'm going to take the restriction. X has got to be bigger than or equal to 1, right? Maybe that should have been -1. It should be -1, I'm sorry. Okay? I'm going to plug that in here now. Right? So at -1, when x is -1, I'll do it this way so it's a little easier for you to see. -1 plus 3 is 2, right? Yeah, sorry. I forgot to put the negative on it.
Could you do me a favor and write it like how you wrote the first one? So you have the left of the
So f of -1 equals -1 plus 3, which equals 2. So -1, 2. This one is a closed dot. Why is it closed? Less than or greater than or equal to, right? And now it says it goes off to the right. Yes, that's going to be your next point. Up 1 and over 1, and then
So we have.
I was on my phone, I don't know what happened. Where did x equal -1?
We graphed the other. so
that's the second one.
Actually, it says x is greater than 1, not -1.
Right, but that's saying whenever you graph it, It's got to be bigger than -1. So I want to know what is it when x is -1 so I can go off forever this way.
Ooh, it doesn't make any sense.
Sure it does. Watch this.
Okay. All right.
Watch this.
All right.
All right. F of x equals, let's say x minus 1.
Yeah.
-1 up 1 over 1, right?
Yep. Yeah.
There's my line.
Yeah. That looks about right.
Okay. Oh, it's supposed to be x minus 2, 1. Okay, let's say if I said, okay, make it when only x is greater than 3.
Okay.
Well, so I got this line.
It went out.
Why do you keep having to do that?
I don't know. Just say aloud.
Wait, so when you find f of x at that point, you're closer to
Yeah.
Yes. All right, so I would go 1, 2, 3. So what it's saying is, from this little dashed line that I'm drawing on here, I only want the right side of it because I only want it when x is bigger than 3. So none of this is even relevant anymore, right?
Yes, because we just need it.
But
I would just need it here and to go off forever this way. So instead of doing the whole thing and erasing what I don't need, if I plug in where it starts, if I plug in where it starts, then I can go from that starting point. It's just a little less work for me
but
to
why
have to
do you
do.
put -1 instead of 1?
Because that's how you find the coordinates.
I'm just saying, I'm just looking at another example. I'm showing you
Okay.
another example.
Yes.
Yeah. He was saying why, I didn't want to confuse with this one, why are we plugging that value in? And I'm showing you why we're plugging that value in. We're plugging that value in because it's easier to plug that value in than it is to draw the whole line and erase what doesn't apply. Okay? Now, do you see why we had to restrict this to make it a function?
Because you're on the same line.
Exactly. If I ran a vertical line test here, if this was filled in, it would fail,
Because it's the same.
right? So by making one open and one closed, I've now satisfied the conditions of a function. So now I have a function that's made up of different pieces.
So that's still a function?
That's
So
why
why
it's a piecewise function.
So why
Yes,
would
it's,
someone use this?
we're gonna do several. We'll do several.
So every time it's gonna be one closed one.
Say again. No, you're not connecting. I was just showing you. I was showing you how it would pass the vertical line
You have
test.
to
So I'm
write.
saying, the white dots.
Oh, if we drew that line all the way out, those points would be on that line. No, no, no.
So did we write down where it's what line they're on, -1? Did we write that down?
What do you mean?
They're both on the same.
You're just looking for, I'm looking for your graph is what I'm looking. And so to find your graph, and if this way confuses you, here's what else you can do. You can plug in -1 and then use that for 1 point, and then plug in a point smaller than -1, -2, plug it in, and then just connect them.
So every time it's gonna be shaded with one up.
Yeah. If they're on top. Okay, so which way is x smaller than -1? Which way does it get smaller? Left or right?
To the left.
Is this x and this x, this is -1, this is -2, so it gets smaller to the left.
You're going
So is it kind of like shading almost? I don't know.
Yes, it's exactly like shading, but you're just picking the part of the graph that's on the side you would shade on.
So could you like,
You could pick a point, you could take this point and then pick one that's smaller, you could. All right, let me show you, because these definitely get way more complicated than this. We'll have some that have 3, 4, and 5 pieces, not just 2 pieces. It's just more steps.
So on a line, on a point that's on one of those lines, you could put it in that and test it and see if it works.
Yeah.
It's like, let's say, like,
What are you going to test for? Tell me what you're testing for.
to see if it's right, I guess. Or,
Well, the only thing you'd really need to look to see if it's right, if I'm right here, if this coordinate is -3, -4, and I don't know if that's what it is that x less than -1?
That's what I was doing.
Yes, yes. Yeah.
Okay.
So like, I could test like 0, 0, and then if it didn't work.
Well, but 0, 0 is not on that line. It'd have to be a point on that line.
So like, x is -1. Okay.
But you're only looking at the x's. I think y'all are making this way harder than what it is. All right, look at this one. Come on. Let's say f of x equals,
Let's try to work this out by ourselves.
Yeah, can you give us one?
yep,
I need to break the YouTube.
real quick if you hadn't, because the bell's going to end up catching us in a minute. All right, so I've got two different equations here. Both of them are lines, okay, but they're both restricted at 3. One goes to the left forever, one goes to the right forever. All right, so if I look at the first one, if I plug 3 in, right, I get, was 3 minus 1? 2. So I get the 0.32. Is it inclusive or exclusive?
It's inclusive.
It's inclusive. All right, so 3, 2. Now I know it's less than, which means it's going to the left, right? So I need to either do the slope from here or pick an x that's less than 3. Whichever you want to do, it doesn't matter. Okay? Slope is the easiest. It's 1. If I go to the right, I go up 1 over 1. But here, it's down 1, left 1, right? Regardless of how you did this, if you plugged in an x that was less than 3, then you should have gotten, if you plugged in, let's say, 2.
Wait, wouldn't it be different because it's -1?
What's -1?
The.
That's just, don't even look at that when you graph the first one. Yeah. And this one would be crossing. And if you use that as your other point, that's fine too, because that is less than. Oh my goodness, just let me get through this lesson. All right. Now what I want to do is I want to look at this one, right? This is a horizontal line. You got a question, Goldie?
Yes. Okay, why would you go 1 and then that way, also like that? Like for your slope, like when it's in 1 over 1?
Mm-hmm.
So why would you go like here and then there, like to the right?
You
Because
can't
if
go
you,
up.
yeah, I can't go up because I can't go to the right.
A negative over a negative, same thing as 1 over 1.
At the end of the day, when I connect it, it's still got to be going uphill. Yes, you will. Plug in a point that's smaller to get it instead of plotting by the slope. Horizontal lines are easy. Y'all looked at that and you thought, oh my gosh, I'm not going to be able to do it. But you can, because at -1, I got this horizontal line, but it's only good when x is bigger than 3.
So, open circle and then that way. Yes. Done. All right.